Welcome back to another Mech 1000 video. We're looking at the blueprint reading textbook unit on geometric tolerancing. And in the last video, we looked at the first group of geometric tolerances known as form tolerance. And we're going to resume that discussion with the next group of tolerances known as orientation tolerances. These tolerances include angularity, parallelism, perpendicularity, and profile can be considered one of these as well. So an angularity tolerance has to do with the angle at which an axis or surface or edge is. So for instance, we have a hole here that is specified at a 60-degree angle with respect to datum A. So datum A is identified as being the bottom surface. So this varies somewhat between the angular tolerance, just the dimensional tolerance. So we're not necessarily worried about the angle being within like 59 to 61 degrees, but instead we're looking at a tolerance zone. Because of the geometric tolerance being specified as an angularity at point 2 with respect to datum A, that means that there is this imaginary zone that for the axis of this hole would be essentially cylinder shaped. Okay, and it's going to have this width to it of 0.2, and if I kind of color that in, shade it in with my little pen here, as long as the axis of that hole stays within that cylinder-shaped tolerance zone, then it is considered acceptable. It meets its geometric angularity tolerance. And if it goes outside of that zone at any point, then it would be rejected. Parallelism is another orientation, geometric tolerance. And so, again, it works in a similar way. We have to establish some sort of datum by which we are comparing. So in this case, datum A is the surface of this bottom hole. And what we're saying is the top hole needs to be parallel to the bottom one. And the tolerance zone has a diameter of 0.2. So again, we've got basically like an imaginary cylinder here. If I shade in with my pen, has a diameter of 0.2. And as long as that axis going through the center of that hole remains within that tolerance zone, it is considered acceptable. Perpendicularity is another orientation tolerance that establishes a datum. So we've got the surface here, datum A, and the axis of this cylinder needs to be perpendicular to datum A. And again, we're given the size of a tolerance zone with its diameter. So we have basically, it's like a cylinder in 3 dimensions here. And it has a diameter of 0.4. And as long as that axis going through the center of that cylinder remains within that tolerance zone, it's acceptable. So let's look at an example here that puts some of these orientation geometric tolerances into play. So the first question here is, how many geometric tolerances are specified? Looks like 1, 2, 3, 4. I count 4 geometric tolerances. How many of these tolerances are considered of the orientation type? So that would be the ones we just looked at in this video, which include parallel, that's one. Flatness is form, not orientation. Perpendicular, that's an orientation one. Cylindricity, again, is form. So 2 out of the 4 are considered orientation types. Do the geometric tolerances apply at MMC or regardless of feature size is what RFS stands for. So if they only applied at MMC, we would see a little symbol, an M with a circle around it. I don't see that there, or there, or there, or there. So that means they are applied regardless of feature size. How many surfaces serve as datum features? So the hole going through here, that's one, that's datum A. And B, well, we have a datum B here, and it looks like it's the inside surface here. Okay, I see, which is actually a flat surface. This surface right there. I'm not doing a very good job of drawing it, but yeah, that would be datum B. So there are two datums, A and B. How much geometric tolerance is assigned to the 0.2 diameter? So if we look at these geometric tolerances, which one, we first need to figure out which one it's referring to. And here it is the 2.0 diameter, 2.000 diameter. We found it. Now, it has this tolerance here as part of the dimension, but that is the dimensional tolerance. The tolerance applied to the geometric tolerance. So geometric, I want to establish here the difference between geometric and dimensional. The geometric tolerance is 0.002. It's right there. Now let's follow it up with this question. How much size tolerance, how much size or dimensional tolerance is assigned to that same hole? That is what's actually indicated in the dimension itself. And if it hadn't been indicated there, right there in the dimension, then we would be down here in the title block looking at this one right here. But since it is dimensioned, or it is given in the dimension, we look up here and we can see that size tolerance is +0 minus 0.005. And that does it for our geometric tolerance chapter. So if you have any questions, be sure to post them on the Blackboard discussion board or ask in class.